Hello, everybody. So what we're going to be looking at today is programming homework number 3. So we're just going to talk our way through a little bit of it, the stuff that you need to get started here. So first thing to notice is that I'm in the programming assignment here in Canvas, of course. Um, you see the PDF right here, and you see a zip file right here. Now, I don't think the zip file actually has any M files this time. You do need a file that you're not going to write yourself. It's going to be the ds quicksort function, but we're going to write that today. So you watch the video and that's how you're going to get this function. Okay, let's see what else. Also, the due date is going to be April 14th. Right now in the PDF, it says April 12th, but I'm going to change that when I fix some other typos in this file. So yeah, so let's go ahead and try to get started here. So yeah, what are we going to be doing? So what we're going to be doing today is we're going to look at this programming 3 PDF and see what we're going to do. So this programming assignment, most of it is going to be working through the merge sort algorithm. So problem 1 asks you to describe how the recursive merge sort algorithm works in your own words. Now, I'm not good at words because I'm a mathematician. However, if you look at the previous video for section 5.4, I probably talk about merge sort a lot in that video. So just go ahead and watch the video, make sure you understand how it works, and then, make your best shot here at problem 1. Probably whatever you write, if you have a basic understanding of how merge sort works, is going to be fine. So don't stress out about it, okay? So you just literally type a paragraph here. That's what you do for problem 1. Problem 2. So if you do know how merge sort works, then you know that the merge sort algorithm is actually split into 2 different algorithms. So we've got one here in problem 2, and it's algorithm 10, merging 2 lists. And then down here in problem 4, you have algorithm 9, a recursive merge sort. And the reason we do merge first, which we're going to do today, and you do merge sort second, is because if you look down here, you see that merge sort calls merge. So you can't do this one and have it work until merge works. So merge has to work first, and then you can code up merge sort. All right. And you're going to code these up, algorithm 9 and algorithm 10, into separate M files. So I'll have a little notepad thing open here with some notes. So merge sort consists of 2 different M files, right? It's 2 different algorithms, but for us, we're going to implement them as functions in M files. So that's why I'm saying M files there. So one of them needs to be called ds merge sort, and that's the one that actually sorts your list L. And the other one is called merge, where you give 2 lists and it outputs a single list, right? So like that, like that. So this one combines 2 lists. The first one sorts 1 list. All right. And we're going to code these up. Well, today we're only going to code up merge. Okay. Now, do pay attention to the fact that, like, I'm calling the function ds merge sort. If you don't call it that, then the script down here given in problem 7 won't run, because of course I used ds merge sort. That's what I called it. So if you change the name, you've got to change the code in problem 7 to match your stuff. Okay. So having said that, let's go ahead and get started. We are going to code up Quicksort today as well, but we're going to look at merge first. So here's algorithm 10, merging 2 lists. Now the pseudocode's right here, and we're going to have to do this in Octave or MATLAB. But before we even do that, I'm going to show you how it works just typed up here. So I think I have it copy pasted, I hope. There we go. So here's how it's supposed to work. So you define, well, not you, like, it works internally to the ds merge sort. So there's never really a reason you run it yourself. But if you want to run this to test it, the idea is like this. So first thing you do up here, you type in a list. The list needs to be in order. So 1, 3, 5, 7, that's in order. You need a second list. Here's a second list, 2, 3, 4. That's in order, right? And then what merge is supposed to do is it's supposed to take these two lists when you run merge L1, L2, and then it's supposed to combine them into a list, and it's supposed to stay sorted. So you give it two sorted lists, it combines them, and the result is still in order, right? That's how it's supposed to work. Okay, now I'm going to show you how it works down here, just to remind you. So let's get rid of these and go. So merge starts with this data. It knows L1, knows L2, and then you have L, which is going to be your output, and that starts out as empty. Okay, so then what you're going to do here, does this work? Hold on. Yeah, okay. So you compare the first element of L1, which is 1, to the first element of L2, which is 2. So you just compare those. Whichever one is smaller, so in this case, 1 is smaller, obviously, you're going to take that one, the smaller, you're going to erase it. So we actually have to take it out of the list. And what you're going to do with it is you're going to put it into L at the end. There you go. That's the first step of merge. Now, when you do that, now you took that away from L1, so now L1 is smaller. But then you just keep repeating this process. So now we're going to look at the first element of L1, which is 3, the first element of L2, which is 2. Which one's smaller? The smaller one is 2, of course. So you take the 2, you erase it, and again, you put it at the end of L. Keep going. So now you compare the first element of L1 to the first element of L2. So we have 3 and 3. Which one's smaller? Well, if they're the same, it actually does not matter which one you're going to use. The way the code is going to be written, it's going to end up taking the second one, but that literally doesn't matter at all. So 3 and 3 are the same. So we take whichever one. I'll take the second one here. Erase it. Put it at the end of L. Now these are our two lists. Now you look at the first element of L1, first element of L2. The smallest one is 3. Erase it. Put it at the end of L. Notice that you can see why it doesn't matter now which 3 you take first, right? Whichever 3 you took first and whichever 3 you took second, it doesn't matter. They're going to go 3 and then 3. And then when you're done, there's no 3s. So you can't even at this point tell whether the first 3 came from L1 or L2. Same thing for the second one. So that's why it doesn't matter which one you take. Anyway, we keep going. So you compare the 5 and the 4, the first elements. The smallest is 4. So you erase that 4. You put it at the end of L. So we're here. Now at this point, we've run out, right? There's no first element of L2. L2 is now empty. And so what you do is when one of the lists is empty, you're done almost. When one of the lists is empty, you just take all of the remaining elements, which are from the other list, erase all of them, however many there are, and you put those at the end of L. And at this point, L is in order, and L1 and L2 are empty. And you're done. So that's the process of the merge algorithm. So when you look at the pseudocode just does exactly what I just did right here for merging those two lists. Okay, so that's the merge algorithm, and we need to implement it now. So let's go ahead and figure out how to do that. First, we have to figure out how to use Windows here. Let's put this on the left. Let's put octave on the right. Got two heads here, which you guys don't care about, but for 3D modeling, it was wrapping one head to another head for reasons. Okay, so, all right, so we did this. How do I make this go away? Can I make this go away? Yes. All right. So now we want to actually code this up. So I'm going to go here into programming 3, which is just an empty folder. And we're going to go ahead and start coding this up here. Okay, so algorithm 10, merging two lists. And you're going to see a couple of tricks here that maybe are important. I'll try to point them out here. So we need to code this up. It doesn't matter what we call it. So yeah, so it's a function. It has output. And we're going to call it merge, not meg, merge L1 and L2. Of course, there are no subscripts, so they say L subscript 1. I'm just going to say L1. Also, I'm using uppercase L. You use whatever you want. Okay, so that's how we get started. Now, then let's go ahead and try to do this code. So what do we do first? First, it says L should be an empty list. So the variable needs to exist, but be empty. So the way you do that, there's a few ways. Here's the easiest way. So square brackets with nothing in them, right? That's an empty list. So this is how you create an empty list. Maybe let's put that down here, just a note. Is an empty list. So L equals that. Type hard. So L equals empty brackets creates an empty list called L. All right, so easy enough. So that's how we do the first step here. Let's get rid of that. So mission accomplished. Then it says, while L1 and L2 are both non-empty. Well, there are a lot of ways to check if L1 and L2 are non-empty. So here's a way to do it. So let's just do like L1, let's L1 be empty, and L2, let's actually put something in L2. All right, so MATLAB and Octave actually have a nice command called isEmpty. isEmpty. And so if I do isEmpty L1, it returns 1, which is true. And if I do isEmpty L2, it returns a 0 because L2 is not empty. So 1 is true, 0 is false. So this built-in isEmpty command can easily check if something is empty. So that's how we're going to do our while statement. While L1 and L2 are both non-empty. So the key there is non-empty. So this is empty. We want is not empty. So you're going to have to go while, if I do it this way, is empty L1 and is empty L2. I've actually done the exact opposite of what I was supposed to do, right? Because this is if L1 is empty, and this is if L2 is empty, and we want non-empty. So we need not here. So a tilde is the not symbol in MATLAB. So it's not an exclamation, it's a tilde. Not is empty, not is empty. That'll do it. That's how we check that they're both non-empty. Now, while we're at it, let's just go ahead and put an end there, just so we can see what's inside the while. All right, now inside the while, what are we going to do? Well, it says remove the smaller of the first elements of L1 and L2 from its list. Well, how are we going to do that, right? We have to know which one's smaller. So in order to remove the smaller of first elements of L1 and L2, we have to know whether it's L1 or L2. So you're going to have an if statement. If L1 1 is smaller than L2 1, right? And you could just use an else here, but I'm going to use an else if just to make it obvious what we're doing. Else if L2 1 is less than or equal to L1 1. Have to be careful there. Then in. Right? So what we're going to do here is you actually have to know whether L1 1 is smaller or if L2 1 is smaller. And you do something different in each case. So that's why I wrote this whole block here before we put in the details. So if L1 is smaller, what are we supposed to do? So remove the smaller of the first element of L1, if L1 is the smaller one, and put it at the right end of L. So we actually have to put it at the right end of L first, and then we can remove it. So let's go back here. Let me just make a list here. Let's say L1 is this, equals, and let's say L is, well, let's just say that it's empty right now, which it is. So how do I take away this 1 and put it into L? So the easiest way to do it is like this. L equals L, L1, 1, right? The reason that's going to work is because, well, let me just show you. So like, suppose you had this, like x equals 4. I wrote 3. Okay. X equals 3. Now, how do I put something after that? Lots of ways, but here's a couple. X equals brackets, X, and then you can put a number, and X is just 3, and 7 is next. Now you've got 3, 7. Then you can do the same thing. X equals X, and then another number, like, I don't know, 4. Now that goes on the end. So this type of line is an easy way to put something at the end of what was already there. So X is X, and then a 4, right? So we can do the same thing here. So we're supposed to be putting the smaller of the first elements of L1 and L2 at the right end of L. So you just go L equals L, and then L1, 1. But you only do that in this first block because that's if L1, 1 was the smaller one. Now, after you do that, you need to erase it from the list, right? Because it says remove the smaller of the first elements. So we need to figure out how to erase L1, 1. And again, there's a lot of ways to do that. So like, let's just look at this X here. So X is 3, 7, 4. How do I erase the 3? Several ways. Here's one way. X1. So X1 is 3, right? How do I erase it? Well, we already know how to do empty, right? Remember, square brackets is empty. So if I do first element of X is empty, it erases it. Now the 3 is gone. So that's one way to do it. Now, if I do, there's other ways you might prefer. So another way to do it is just to say, well, we want to erase the first element. So the ones we want to keep are starting at 2 and going to the end. Right? So since we started at 2, we skipped the first element. Now it's gone. Right? So you have choices here for how to do that. Which one's the best? I don't know. L1 is, I don't know, L1 to the end. I'll do that way. It doesn't matter, right? So that will erase the first element of L1. And so this block of code is what you're supposed to do if L1, 1 was smaller. Now, The next block is what to do if L21 is smaller. Well, you do the exact same thing, so we can just copy this and paste it. But the difference is we should not have been doing L1 here. We should have been doing L2, removing the first element of L2 and adding it. So change all the L1s to L2s, right? And so that block of code now implements this: remove smaller of first elements of L1 and L2, put them at the right end of L. Also, now that I've written it here, I'm just going to say the smarter way to write this is to just write it this way. Either L11 is smaller or it isn't, right? And if you write it this way, you know that there's no third possibility, right? You either do this block of code or you do this block of code. There's never a case where you do neither. And if you write else if you write what comes after this wrong, if you write your condition wrong, then this function will fail. And so that's why it's best to do it this way. So one of these blocks will happen. Okay, now let's take a look at what happens if I just run this code right here. I'm going to save this. We need to save it as merge.m. Come here to the command window. So I need some code here. So let's just go ahead and take this L1 and this L2. And now let's run merge L1 and L2. Now we're not done with the function, so it's not going to work correctly, but it'll do something. Here's what it does. So if you remember, what happened when we actually tried to trace through this code was this. I'll type it again. I'm going to have to erase this, but here's what happened, right? So the short version was this. You first get rid of the 1, put it here. Get rid of the 2, put it here. Get rid of one of the 3s, put it here. Get rid of one of the 3s, put it here. Compare the 5 and the 4, get rid of the 4, put it here. And at this point, this list is empty, right? And 1, 2, 3, 3, 4, that's what we have here. 1, 2, 3, 3, 4. Because our loop, we're only in this while loop when both of them are non-empty. So of course, once one of them is empty like this, then the function stops. So what are we supposed to do now? Well, we know what to do now, right? When one of them is empty, you need to take what's left and stick it after the 4. And if we look at the code, the pseudocode, it should just tell us that. So let's look at the pseudocode. If the removal makes one list empty, then remove all elements from the other list and append them to L. So when this block of code is done, then we do this. Now, they wrote it here inside of the while loop. To me, it makes sense to do it after the while loop. So I'm going to do it after the while loop, even though they put it in the while loop. Because the reason I'm going to do it that way is just because if it's in the while loop, then technically every time through the while loop, it's checking if they're empty. When we don't need to do that, it's only going to be empty one time at the very end. So we don't need to do it there. So I'm kind of deviating from this. I'm going to put this if statement here. So that if this removal makes one list empty, then do this. So we need to check that. So we have to remember again how to check if one of them is empty. So basically, if L1 is empty, and you could do this, if is empty L1 equals 1, or you can just do if is empty L1 because the 1 will mean true. Then we're going to do something. I'll have to put a line there. The other possibility is if L2 is empty, then we're going to do something. Now, could you organize these two if statements together in some kind of if-else thing? Of course you could, but I'm just going to do two separate blocks. So if L1 is empty, what are we supposed to do? So let's look back here. So remember, if L2 is the one that's empty, right? Here, I'll do this. So if L1 is empty, like it is now that I've changed it, then what you need to do is L2 needs to go at the end of L, right? So if L1 is empty, L2 goes at the end. If L2 is empty, L1 goes at the end. So it's the other list. So back here to the code, which I'll find, there we go. So if L1 is empty, then what you need to do is put L2 at the end of the list. And down here, if L2 is empty, then you need to put L1 at the end of the list. And that bit of code will do that little bit where it just takes the 5, 7 and sticks them on the end. Now, technically, I just cut that and I actually removed it from L2. And here, I'm not bothering removing anything, right? Like, I'm not doing the equivalent of this where I erase stuff because we don't need to. At this point, we're ready to return L, and returning the correct L was the only thing we needed to do. We don't actually care if both lists end up empty. It's perfectly okay to have like the 5 and the 7 there when the function ends, because when the function ends, you only care that L is correct. So adding these two blocks of code here should finish off this merge function. And if we run it again, this time it should have the 5, 7 at the end. There it is. Okay, so that is how you code up the merge algorithm. Awesome. So now what you need to do is you need to code up this merge sort. So what were you supposed to learn from L1 here, or sorry, from merge here? Couple of things, right? You were supposed to learn how to erase elements. Which did we put those in here? Creates an empty list. What else did we learn how to do? We learned that, like L1 1 equals empty will remove L1 1 from L1, right? That's how you can erase an element. Also, L1 equals L1 2 to the end. That's another way to remove the first element. Right, so there's multiple ways to do it. So a couple of different things you can try there for different bits of code. And also you have this isEmpty function that you probably weren't aware of, but now you are. So there you go. We've implemented the merge function. What's next? So the other thing we're going to do is we're going to implement Quicksort. So Quicksort is a merge sort like algorithm. It's not the same, but it's not too far different. And you're going to code it up. Now, the reason I'm not doing like a whole lecture on this or anything is because if you look in the textbook, which I think we can do, nope, here, nope, here. If you look in the textbook here, Quicksort is actually just one of the exercises. Okay, so this is Quicksort. So they don't spend that much time on it, so we're not going to spend that much time on it. Let's go back and look at it. So here it is where I describe it, and let's see if we can figure out how it works. So I'm not going to go into too much detail here. Maybe let's try to do a quick example of it. See if we can follow along. If not, then we'll try something else. All right. So let's see how it's supposed to work. I guess we can try it with this one. I see a 2.5 there. I don't like that. So I don't know if we're going to trace through the whole thing. Let's just put like a 3 there. All right, so let's follow through this. So how does Quicksort work for sorting a list? Step 1, taking the first element A1, which is 10. You know what? I don't like that first element. I'm changing it. I'm going to go 5. Sorry. But it'll make it, I think, better to have it this way. Sorry. So taking the first element, A1, form two sublists, L1 and L2, the first containing the elements less than A1 in the order they arise, and the second containing the elements greater than A1 in the order they arise. Okay, so that's pretty complicated sounding, but what's it mean? So what it means is this. It means you start out with two empty lists, L1 and L2, right? And you take the A1, which is 5. So you go, A1 is 5, okay? So this is what we know so far. And then what you're supposed to do is the first list, L1, contains the elements that are less than A1, which is 5. So L1 is going to contain everything less than 5. L2 is going to contain everything greater than A1 in the order they arise. Also, it doesn't say what to do if they're the same as A1. And I believe the answer to that is it doesn't matter which one. But I see in step 2, A1 goes in the first sublist. So maybe we will actually put it into the first sublist. So what we're going to do is this is going to be less than 5, less than or equal, actually. And then this is going to be greater than 5. So that's what we're going to do. Right? And it's only 5 because that's what this is. Right? And you do it in the order that they arise. So like starting at A2 basically. So you do the 8, where does the 8 go? Goes here. 9, where does the 9 go? Goes here, right? Big list. Where does the 1 go? Goes into the first list. 4, where does that go? Less than 5, so it goes first list. 6, less than 5, greater than 5, greater, so it goes down here. 8, where does the 8 go? Second list. 2, where does the 2 go? Here. 3, where does the 3 go? Here. 0, where does the 0 go? Here. And that's the end of the list, right? So then what do? You are going to take the step 2, which is A1 is put at the end of the first sublist. So you take the 5 goes there. Okay, so now you have these two lists. Now, then it says the procedure is repeated recursively for each sublist until all sublists contain one item, right? So you see, now we've got two lists. Well, you can do the same thing for L1 and the same thing for L2. So we're going to end up calling the function's going to end up calling itself. Also notice that we kind of sort of started sorting it, right? Because it was completely out of order up here, but now L1 is all the small elements and L2 is all the big elements. So even if you just stopped here, right? Like if I took just all of L1 and then I took all of L2, right, which is here. Now that's not in order, right? This is not in order, but it's closer to being in order than before, right? Because these are all the small ones and these are all the big ones. So it's not sorted, but it's closer to being sorted. Okay. So if you took this part and sorted it, and then you took this part and sorted it, we would be even closer, right? And so that's how the quicksort algorithm works. And it's kind of like similar to merge sort, but it's also kind of the opposite of merge sort. So yeah. So let's try to code it up and see how hard it is to code, because I don't remember. We're going to find out now. So let's do this. So what is it? No, it's a function. L equals ds quick sort L. All right, so let's see if we can code this up. Helps if you spell it right. So how should this work? Well, we need to do this. So we need to take the first element A1 and form two sublists L1 and L2. All right, so we need L1 and L2. So this, similar to the merge algorithm, we have to create empty lists. We need an L1 and we need an L2 so we can start putting stuff inside of those lists. All right. The first is supposed to contain those elements that are less than A1 in the order they arise, and the second containing those elements greater than A1 in the order they arise. And remember, this says less than and greater than, but one of them needs to contain the equal. And I think we decided that it was going to be the first one. So all we do is we're going to loop through all of L, right? That's what we did. That's what we did here, right? We just went 8, 9, 1, 4, 6, 8, 2, 3, 0. We just went through the entire list and we stuck all the big ones, all the small ones in L1, all the big ones in L2. So that's what we're going to do here. So we loop through the entire L starting at element 2. So for, I don't know, I equals, I guess, 2 to the length of L. I don't have, it's not called in, so we'll just call it length of L. What are we going to do? Well, we're supposed to compare, we're supposed to be, we're comparing each one to A1, right? Each one of them needs to be compared to the first element. And if it's smaller than the first element, it goes in L1. If it's bigger than the first element, it goes in L2. So we just say if L, right, they're called L here, not A. So if Li is smaller than L1, so if the current element's smaller than the first one, then it should go in the first list, right? This is smaller than A1. This one is for larger than A1. So in this case, this is the smaller. Then you should just add it to this list. Like that, right? And we already know how to add an element to the end of the list because we learned that when we were writing the merge algorithm. So we do that. Now, if it's not smaller than L1, then it's bigger and it should go into L2. Right? So every element is either stuck into L1 or is stuck into L2. Now, also, I said I didn't think it mattered, but I also said that I thought if they were equal, we were going to put them into L1. So if we want to do that, it would be less than or equal. All right. Now, let's just see what this does. Now, I'm just going to print out the L1 and the L2. Obviously, this code is not going to work yet. And actually, let's just get rid of the output variable there. Okay, so this is going to be called ds quicksort. .in. Okay, so just to see how this works, let's go to here. Let's just take this L. there it is. And obviously DS Quicksort doesn't work yet, but let's just see how it splits up the L1 and L2 just to see if it's working. So what do we get? We get 1, 4, 2, 3, 0, 8, 9, 6, 8. What was it supposed to do? Uh, 1, 4, 2, 3, 0, 5, 8, 9, 6, 8. So it did everything correct except there's no 5 at the end of L1. And that's because if we look here, we didn't do step 2 yet. Step 2 is then A1, which was 5, is put at the end of the first sublist L1. So great. So after you do this, what we're supposed to do is L1. Now, L1 equals L1, and we're going to put A1 there, which is actually called L1. So that's what I didn't do. That's the step 2. So if I save it now and run it again, same thing now, except, oops, now it's got the 5 at the end. So splits it into the small ones and the big ones. Cool. So we did step 1 and we did step 2 now. What's step 3? The procedure is repeated recursively for each sublist until all sublists contain one item. The ordered list of n items contained by combining the sublists of one item in the order they occur. Oh, that sounds complicated. That sounds really complicated. But is it? I would say that it is not. So I think that all we have to do is say that L should equal, like we split these two lists, right? So at this point, you've got L1 and L2, and they're not in order, but L1 is all the small elements, L2 is all the big elements. And the magic of recursion says that what I should be able to do is just say, well, what I need to do, if I did this, L1, L2, it would not be sorted, right? I'm going to do it. Right? This is not sorted list, but you still have the elements at the beginning are smaller than the elements at the end, so it's partially sorted. How do you finish sorting it? Well, all you would need to do is, instead of just doing L equals L1, L2, you should call this function on the first half, and you should call the same function on the second half. So what you're saying there is, instead of just returning first half and second half, you should quicksort the first half and quicksort the second half, and then put them first part, second part. So if I do this, what's going to happen? Now, it's possible that it won't run. But let's see. Yeah, max recursion depth exceeded. Why does it do that? Because we never stopped doing this, right? So we should only do all of this code in a certain situation. So the situation that we should do this in is if the length of L is only over a certain size. So if the length of L should be greater than 1, if it's greater than 1, we should sort it. But if your list only has one thing, then you don't need to sort it, do you? So let's see if this fixes it. It does not. So why doesn't it? Let's think. So what's happening? So like if I do this, I don't know if that's going to fix it. It does. But what happens if there's only two? Will this always work? Huh. All right. Let me think about what happens with if you have a two element list that's not in order. So if you have a two element list that's out of order, right? Like if you have this situation, right? Like if you do L1, sorry, if you have L is like 8-1, right? That's out of order, then this code would not work correctly in that case because it'll never do anything here. Uh, right? Let's try it. So this should be broken. Right. It returns 8-1, which is why I put a 1 here at first, because I thought we should be okay with one element lists. All right, so how would this work? So if you had a one element list, no, so what would happen in this case now? 8-1. So let's follow our own code. If you had L equals 8-1, L1 starts empty, L2 starts empty, right? And A1, of course, is 8. So I goes from 2 to length L. So we do have 2. So if L2 is less than L1, so L2 is indeed less than L1, then it should go in the first list. We put a 1 there. And then we're done. No, then you do step 2, which is L1 equals L1 with L1 at the end. So it would put the 8 at the end. And then it would call this function here. Okay, so the problem is when you call this function here with 1-8 and an empty list, then the right thing doesn't happen. I guess. Right? Because I saved this. No, that's fine. Okay. Well, what happened with the big L? Okay, so it works with two element lists. Does it not work with one element lists? Well, what's going wrong? Let's try a couple things. Okay, one element lists are fine. One element lists that are out of order are fine. Two element lists that are in order, fine. So what makes this not work? Okay. Something bad happens there. Let's try to trace through it there with 3-3-3. What if they're 3-3? Does that do it? Yeah, two elements that are the same does not work. Interesting. All right, so let's try to figure out what happens. 3-3. All right, so tracing through the code, in this case, with L greater than 1. So start with these empty. L greater than 1, 2 to length L. So this should be a 3. So if Li, which is 2, so if 3 is less than or equal to L1, which is 3, then it goes into L1. So you put the 3 there. Okay. Then you're done. So you come down here. L1, it should be 3, 3 then. Like that. Oh, I see. And then you call this function again. And when you call this function again, you're going to sort 3, 3, and it's going to go through the same exact steps. Okay. So what we got to do is somehow avoid this happening here. So I think actually maybe if they're equal, right? This first case here was what happens when if the elements are less than or equal to L1, 1. And in this case, with a 3 and a 3, they're both less than or equal to 3, so they both go into L1, 1. I think what would happen is if instead of 3, 3, it went 3, 3 this way, everything I think would have worked out. And so the way to make that just kind of happen would be instead of doing Li less than or equal, just to do Li less than. So I think that's the shortcut way to fix it. Let's find out. Now it doesn't crash. So now does it run with the big L, the bigger one? Yeah, runs fine. Okay, so it turns out that at the beginning when I said this, the first containing those elements that are less than A1 in the order they arise, and the second containing those elements greater than A1, turns out that we didn't actually have a choice of putting them in the first one or putting them in the second one. We should have put them in the second one. That way, when you end up with two the same, they end up going into L1 and L2 separately. I think that'll do it. Let's just check. What if you do 2, 2, 2, 2, 2, 2? All right, so we're good. So same, putting, like when there's multiples of the same number, putting some of them in the first one and some of them in the second one fixes the error. The other way to do it, by the way, would have been to special case this right here. You would have had to do something like this, like you basically would have needed to notice this happening, and then you would have had to say like if length of like L1 is 2, and then if like basically you would have had to not run this code if the length was 2. You would have had to like special case it, which if there's only 2 elements, you either keep them the same or you reverse the order. But that would have been adding something that just is not listed here at all. And so that's why it's a better fix to just change this, which we changed it to actually match the text. But the text is still ambiguous because it says the second containing those elements greater than A1, and it should say greater than or equal to A1. And then that would have been correct. Anyway, it doesn't matter. Point is we now have this coded up. And it works. So I think we're done now. That's Quicksort. Quicksort works. See, it sorts 2, 2, 2, 2. So works. It should work in all cases. Just a comment about Quicksort and merge sort. So I told you that Quicksort and merge sort are related, and they are. And the thing about them is if you go through and you figure out how much work it is to sort a list of numbers, that like if you start out with a list that's already sorted, like if you pass 4, 5, 6, 7, 8, 9, 10 into merge sort and Quicksort, one of them does a lot of work and the other one does almost no work. Like if you pass a sorted list into Quicksort, then uh, I think it does a lot of work, right? It has to go through the list a bunch of times. Uh, I don't know. I'd have to look at it. If you give something that's exactly in the opposite order, like backwards, like 10, 9, 8, 7, 6, 5, 4, into both of these, then like the situation reverses. The one that did more work before does less work. Um, and yeah. So what was the point of all that babbling? The point of that babbling was like the worst case scenario for merge sort is not the worst case scenario for quick sort, right? They kind of have different strengths. Um, so you could pick which one you think will work better based on what kind of data you expect to be giving it. Is it random? Is it going to expected to be close to being in order already? Is it expected to be the opposite of an order? Like how is it kind of sorted already before you start? Um, anyway, so that is Quicksort, which we coded up slowly and badly, and there it is. So after you code up merge sort, which is what you have to do now, then what you need to do is just time the execution of these sorting algorithms. So bubble sort, merge sort, quick sort. So we've already coded these, some of them, right? So let's, we don't need this. So just kind of a reminder, DS merge sort, you write, right? DS quick sort, I wrote in this video. You type it. DS bubble sort, you wrote in a previous assignment. So you have to find it. So you need your bubble sort that you wrote before. So these are the functions that you need. And then what you're going to do is you're going to write a script that just times them. Now, there's one thing I do want to talk about here. I'll copy this right here into my own, a new script editor. So what this is doing is it's storing the time in a variable called QuickTime. And the reason I'm doing that is so I can print it out on the screen later on. Just a way to make the timing script slightly fancier than we did in the previous homework. Right, so here's my timing script. Now, if I run this, there's a typo because the underscore doesn't copy paste properly. If I run it, there's not much to it. In undefined, that's because I didn't copy it from here. Okay, try again, run. Okay, so it ran Quicksort and it told me the time was fast. So you can put a lot of elements in here and it should still be fast. Now the reason I don't want to put too big a number here is because you are going to run bubble sort and bubble sort is slow, right? So here's the problem with this code. So if I open MATLAB here, which we've got somewhere, it's very slow to open, but I think it's going to do it. We just have to wait. There it is. Honestly, this is the main reason I don't use MATLAB, because it just opens so much slower than Octave. Oh, and I'm so bored. Why? What are you doing, MATLAB? Why are you taking so long? Is it because your user interface has more color? Is that what's taking you a long time? Okay, here it comes, everybody. Oh, there it is. Down here, though. All right. So we're in the wrong folder because we're in a folder that I was doing other stuff in. Okay, now we know. All right. So if I go into this folder, we'll see that there's a problem with my timing script. Close. Here's my timing script. Run. Because I didn't create. Oh, that's why it was so fast. I forgot. I was copy pasting from the PDF, right? But I forgot the part where I created the random vector. All right, so let's put that there. Save it. Timing script, 20,000. That's too big. Okay. It's slower now, right? Half a second for n equals 2,000. Point is that the script works, right? And if I open up MATLAB though, and oh, it updated. Look at that. It updated automatically. If I run this, it's going to have an error. Or it won't have an error. I really thought it would. All right. So I thought that the error that I was going to have was on this fprintf command because fprintf is actually file print. So I should have used printf. Shouldn't have. Okay, well, I think I should have used sprintf. No, that's for string. Well, I guess I'm wrong. I thought that there was an error that was going to make me want to use one specific printf command. Because if I go over here, if I put printf here, this is fine. Right, runs fine. But if I run this one with printf, I get an error because it doesn't have printf. So just a minor difference in how MATLAB and Octave work that make the script work in one of them but not the other one, depending on whether you use the correct printf command or you use the wrong one. So fprintf works in both, so let's use that. Okay, and speed between MATLAB and Octave is going to be pretty different. MATLAB in particular is very fast at these kind of loops that involve vectors, whereas Octave is not by default unless you install special libraries and stuff. So it's hard to pick a number for n that actually works well for Octave and for MATLAB, right? Like I can go up here and change this to 20,000 on this, and this is still just 1/3 of a second, right? Whereas if I run the same code here, it's obviously more than 1/3 of a second that we're waiting right now. So yeah, 6 seconds, right? So 3 and then times 6, so like 20 times as slow in Octave. Now don't read too much into that. Don't that should not go into your brain as Octave is slow and MATLAB is fast, because when you get down to real number crunching with big matrices and stuff, if you set Octave up properly, then it will be very fast as well. But just like out of the box, Octave isn't going to use more than one processor, and it has like a special library for math that doesn't take advantage of all your processor's capabilities, whereas MATLAB has better libraries installed by default and so on. So you can make Octave fast, it just isn't right now. Okay, anyway, so I just wanted to look at that fprintf issue just to make sure we were okay in Octave and MATLAB. And we are, so that's good. So yeah, I think that's it for this video. So in that case, homework will so in that case, your homework is going to be due, remember, April 14th. You got like 2 weeks from Wednesday or something to do it. And really, you just have to code up the merge sort algorithm and run a couple of things. So it's a really straightforward assignment. I think you guys will have no trouble. come to office hours if you do need help. All right, so that's it. So talk to you guys later.